Alright, these things come with little tabs on them, and I'm just taking those tabs off. I snipped most of them off. Now I'm just shaving off the little edge just to get rid of it. Yep, powder into the bucket. Okay, now these are the strips of LEDs. They're really cool. They're very dense. I think it's 144 per meter. And I'll be using these little micro tabs that I had created to help me solder them together. So you turn it around this way. You look at those pads, and the idea is just to solder in there and fill in the gap. And then you take the other strip, and you'll see that the arrows on this one are on the inside, and you make it so the arrows on this one are in the inside, and that connects your data on the middle pin, your ground on the center pins or the inside pins, and the two outside pins will be plus 5 volts power. And you'll end up with a nice connected set. Let's see what happens when I solder it together. So I'm going to use a clamp, just simple clamp, to hold it in place while I do the work. I'll put a little bit of flux on the end there, and we'll see how it solders. Okay, see how this works. Get it nice and hot right on the board. Melt the solder into the join and hope. That's what it's all about. Did that work? I think so. Is it in focus? Can't see. But the board looks connected, so I'll test it with, oh, that one on the right doesn't look great. But the other two look okay. I'll test it with see the continuity of that, and then get back to you in a minute. So if this is working, the outside two should have continuity, because they're, yep, and the inside two should have continuity. So that's my positive and negative. Now the data is tougher, but I'll just touch here and see if we get, yeah. So the top of the chip is seeing this, so that means our data line is connected. Now I'm going to fast forward and connect the next strip. Now that is backwards, all right? What happens with these strips is you want the data to come down, follows this line here with these arrows, goes across the little board in the back, which is holding it together, and then goes up this way. So we'll put this one in this orientation here, and once it's done, we'll have a look at it and test it again. Okay, just soldered up that last one, that second one, and it looks pretty good. It's not the strongest join in the sense that this is structurally not going to hold, but the idea is You'll then use maybe some GE silicone glue, and you can throw it on here, and all these little cuts are designed to hopefully hold it better. You might even put something under it. And in fact, these 3 holes may touch on the back side to these, so you may slip a little piece of paper or something under there to prevent that if you're not using this piece. I'll talk about these vias in a second. Anyhow, so I'm going to test the continuity on this. If it can stay somewhere. Alright, so in a perfect world, again, plus is joined to plus. We have continuity, minus is minus. I hear it. And then data we'll try and test just by being on the top of this one and the top of this one. And it seems to work. So they are connected. So this little board's intended to help me out to make this 3 by, I think it's 42. So I'll use so you can see that this one's on here, right? So then we'll go to the other end. And at this end, I will put this strip in this orientation and put another connector here across these 2. Now this one will be by itself, and that's where you'll have your primary voltage data coming into this system. So let's see if I can show you what I'm going to do with that. So that via line is intended to be weak, and if I'm strong enough, I'll break it apart. So this is not needed, but this piece provides me the ability to put it at the end of this one strip, and so underneath I'll have 3 points in which I can solder my input voltage, ground, and data to, and it'll all be flush, and so on the top you won't see anything. That's the whole plan and the desired state. So I'm going to solder it up the rest of the way, and then we'll look at it again. I'm suspect of my data ones already, but I'll test those by running actual code on it. Okay, got that good. Got that good. And these will never work here. In the middle, you really have to test it at the joint itself. If you feel, if that doesn't work, you should really run code. And yeah, you can see how this one got a little bit melted. So let me work on it. Talk to you later. Okay, so I took a moment to solder on my 3 leads. Alright, data, voltage, ground. And I'm just going to trim them down. Now, I'm going to probably put a little piece of electrical tape on that in a minute, so that, because this side, when we have our strip, this side here will be down and may touch those leads there. So I'm just going to cover them up a little bit. Well, orientation this way, you know? Okay, so I'm going to get this last one in. Test the strip. If it doesn't work, look for the bugs. So it was a lot harder to clamp with the wires in there underneath. But of course, you have no tape in there yet, but we'll see what we got. So, in a perfect world, I've got red properly done, black, and white. So let's test red. We can test red by going all the way over here and out to the 3rd strip. 3rd strip. Nothing. Okay, we got something there. So that's inside, inside, outside. That's correct. So black is inside, inside, outside. So we've got continuity. Now with data, tough to test. All we can really do is see if we get continuity over here. And we do. So I'll hook up a little Arduino program to run this, and if lights make it to the third string, it means we're good. Okay, we haven't fired up the Arduino yet, but I thought I'd just tell you how it's connected. This orange wire is a data pin which rides into this white alligator, comes out over here and into our data pin that is the center here. And this strip has our single connector on this end, down to that end to a double connector, back here to a double connector holding these two together, and all the way up. So that's the data. Here we have plus 5 volts and minus 5 volts coming from, look, we got something. That's coming from a power supply that has a fair amount of amperage. 5 volts, I don't know how many amps, but a lot. And the amperage doesn't matter as long as you're 5 volts. Well, the amperage matters in the sense that you need enough, but if you have too much amperage in your power supply, the LEDs won't ask for it, so it won't be using it. In a perfect world, that's actually running some code I had on the Arduino before, which should be cycling all the colors in a kind of a random way. The plus here and the minus here, or the red and the black, just go to the 5 volt and the ground of the Arduino. And these are the plus and ground for the strip. So that's all it is. So the first strip's working. Good. That data connection point here is working. Let me put some code that tells it to have more LEDs lit, and we'll see what happens. Okay. It worked first time. I had a problem uploading the code. I think this code's running so intensely for 126 LEDs that the ability to reset the device is tough. So you may have some problems if you're using an Arduino with more than 120 of these LEDs. Anyhow, now I have a grid, which it's just a string. The data goes up one, down this one, and up that one. So if you're going to talk to it as a grid, you need to use a library or write a function. So this light here, I mean, that would be, say, XY00. To make this 01 and this 02, you have to do some math. Now, there's a library out there called Neopixel Bus and Neopixel, and there's a couple of other super fast ones that are really fun to use, but may not have all the features. You have to write some of them yourself. I'm using Neopixel Bus today, and it's a modification or a code compatible, well, compatible-ish code to the Adafruit library. And if you're starting, the Adafruit library is probably the best. But the Neopixel Bus adds what's called animations. And this is running an animation, and this animation says, for every pixel, set it to a random color, like pink, or whatever that color is now. And then fade all the colors individually to another random color. In this case, it's now moving to a greenish. And when those animations are done, pick a new random color and move to them. So, and then now a pink's coming up. So I haven't told it that the random colors need to be bright, clear, red, blue, green, purple, orange, or whatever colors you can get. I've just picked random anything. So it's not the prettiest thing in the world. With a diffuser on it, it might look really nice. Let's see what happens. But basically, the whole goal with my little board is to get it so you can glue together a grid quickly without having to buy a pre-made grid. Now your grid can be any size. Another advantage of this connector is when you have a lot of LEDs, you need to inject power. And so we have here, without breaking it, I'll show you on one of the chips I have. So when you're connected, on the back of the board, you still have 3 holes. You can inject power into these two pins halfway through your strip to enable it to light the whole strip. Because when you get into the hundreds and hundreds and hundreds of LEDs, it's going to quickly fall apart from a power perspective. The data is no problem because each of these Neopixel regenerates the signal and forwards it on, and you can see it's only going 1/4 of an inch, so there's no problem with that signal propagating as long as the LED itself has enough power to keep the PWM engine running and keeping that color up. It'll have enough power to transmit the data that it's receiving to the next pixel. So that's what I've done today. I've created that little board to make this type of a project for me simpler. And this is going to be installed in a piece of art that my friend is building, and maybe we'll get some photos of that once it's all put together. Have a good day.